Hello everyone, my name is Bob the Astronaut, and today we're going to learn about the vast world of stars. We're all pretty familiar with stars. We see them on most clear nights as tiny twinkling pinpricks of light in the sky. Stars are the topic of countless poems, stories, and nursery rhymes alike. Humans have always been fascinated with the stars since the beginning of time. But just what is a star exactly? And no, we aren't talking about the stars you see in movies or the really good players in sports. We are talking about the kind of star that is a luminous ball of gas, mostly hydrogen and helium, held together by its own gravity that is trillions of kilometers away from Earth. If you ever look up outside during the daytime, the extremely bright thing in our sky that our lives revolve around is a star. It's a ridiculous amount of distance. To show you the scale of distance, the closest stars to Earth besides the Sun, the Alpha Centauri system, is around 4.3 light years away, which totals up to around 23 trillion miles away from Earth. That's a lot of football fields! Starting off, stars are born from something called a stellar nebula, which is a cloud of superheated gases and other elements formed by the explosive death of a massive star. As the cloud collapses, a dense hot core forms, the protostar, and begins gathering dust and gas. Not all of this material ends up as part of a star. The remaining dust can become planets, asteroids, or comets, or may remain as dust. After a small to medium-sized nebula forms the molten core of a star, it takes millions of years for the star to fully mature to adulthood, which can be a pretty hot minute, literally. Once the star develops in age the amount of energy it produces, we then classify it as a main sequence star. These shiny balls of light make up the vast majority of all stars, spanning a wide range of luminosities and colors, and can be classified according to those characteristics. For example, our Sun is a normal main sequence star and requires about 50 million years to mature from the beginning to the collapse of adulthood. Our Sun will stay in this mature phase on the main sequence as shown in the Hertzsprung-Russell diagram for approximately 10 billion years. Down a leader avenue in a main sequence star's life, it will expand exponentially while the temperature will drop from the expansion. A red giant star is a dying star in the last stages of stellar evolution. For average stars like the Sun, the process of ejecting its outer layers continues until the stellar core is exposed. While the dust is present around this star, it's referred to as a planetary nebula, in which it waits until all the dust around it proceeds to drift off into space, as most things do. But what is left is what we call the white dwarf. Not you guys. When a larger nebula size starts to collapse and condense, it starts to form something we like to call a blue star. Now these blue stars are much bigger than your average stars. And not only that, they're some of the brightest and hottest stars, going with well over 30,000 degrees Celsius. But blue stars tend to have the shortest lifespans due to how much fuel they need to keep going. The next step in a blue star's evolution is the red supergiant. Now supergiants come into existence faster than normal red giants due to blue stars using hydrogen at a much faster rate. Supergiants, as the name implies, are many times larger than a normal red giant. A supernova is the violent exploding death of a star. It is caused by nuclear reactions building up in a large star until a supernova occurs. Supernovas can be 100 million times the sun's luminosity and can last for a relatively short time. And now we come to the last stages of a star's life. This stage is separated into three different possibilities: white dwarfs, neutron stars, and black holes. Neutron stars are formed during the aftermath of a supernova. The supernova causes the protons and electrons to fuse and cancel each other out and form a high concentration of neutrons. Neutron stars, like white dwarfs, are dense and small. Usually they are 3 times denser than the sun with average diameter of 20 kilometers. If the mass was any greater, the star's own gravity would cause it to collapse on itself and form a black hole, the other kind of result of a supernova. Alright, bye!